Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So for today I will continue with a new topic which is LAN Topologies. So here is the course outline for today. I will introduce you with the terminologies of LAN topologies, and then we'll continue with different type of LAN topologies, that is bus, ring, star, mesh, and also hybrid topology. So what it means by LAN topology refers to the relationships between the nodes in a network. So in terms of visual representation, the topology of a network can be represented using geometric representation of the relationship of all the links and device, that is station, repeaters, and also um, bridges. Bridges here means the switches. Okay, so there are two types of topology. The first one is physical, and the second one is logical. So the physical topology refers to the physical relationship between the nodes, and the logical topology refers to the relationship between nodes in a network as seen by the software that handles data delivery from station to station, or from one end device to another end device. So there are few terminologies that we need to understand here. The first one is framing. So the terms framing has been introduced as early as in week 2. So frame is used to control the transmission of data. So basically frame sits on layer 2 of OSI layer, and also the TCP/IP layer. So each frame contains a part of data to be sent. So we have header and trailer. This is kind of like a recap, where header and trailer contain the sender's physical address or the MAC address, the sequence number, error, and also the trailer contains the sequence number and error detection information. And then we have another terminology which is addressing. So again, this is a recap. So it ensures that a frame is received by one or more destination. So each station is assigned a unique address. That is, if we are talking about layer 2, so the address that we are talking about is the physical address. When a station sends a frame, the frame includes a source and destination address. So there are three types of addressing, which is unicast, multicast, and broadcast. So this is kind of like a recap, but the knowledge is important for us to understand the LAN topology, um, topics. Next, we need to understand about the baseband transmission. So the baseband transmission means that the whole capacity of medium is occupied by the signal. So it is usually used for digital signaling. For example, the Ethernet. So the baseband transmission allows bidirectional transmission. Whereas we have another one which is broadband transmission. So for the broadband transmission is normally used for analog signaling, and the capacity of the medium is divided into channel using multiplexing technique, and the signal travels over long distance, for example the cable TV or the satellite. So there are three basic LAN topologies, some of which might be not really commonly used in recent days, but it is the basis of the newer technologies in LAN. So we have three main type, which is the first one is bus, second one is ring, and the third one is star. So these two topologies, which is bus and ring, we don't usually use it anymore in recent years. So under bus topology, so basically all stations are connected to the transmission medium. So station here refers to the end devices such as computers, repeaters, bridges, printers, and etc. So here, if you look into the diagram, so the figure depicts a bus topology where all devices, or all n devices, are connected to a single shared transmission medium. So this is the shared transmission medium, that is the bus. So the bus is terminated at both ends with terminators here to prevent signal reflection. So each station is connected to the bus via a passive interface here. So if you have three stations, so you will have three passive interfaces. So here the communication is typically unidirectional along the bus, and this given topology is simple and suitable for a small network, but it has limitation in scalability and fault tolerance. So basically here I have explained earlier on about the passive interface, but when I talk about the passive interface, we also talk about the prevention of the signal reflection. Okay, the use of terminator to prevent signal reflection. So basically, for the signal reflection, it will usually occurs when electrical signal traveling along the transmission medium, here the one in red, okay, such as cable, and when it reaches the end of the medium without a proper termination. So basically, for a signal reflection, instead of being absorbed, the signal is reflected. But so if you do not have a proper termination, so the signal will reflect back along the medium, which can cause many things such as interference, data loss, and also network issue. So like for the interference, the reflected signal, because if you don't have the proper termination, so the reflected signal may interfere new signal being transmitted, which will lead to the signal that degradation. And if signal reflection also can distort the original signal, which making it harder for devices to interpret the data correctly. So the interaction between the station and medium through medium interface. So in the diagram here, we have the passive interface. In the earlier diagram, we have the passive interface. So what is the interface? Interface can be external piece of hardware installed on the medium or included in NIC installed inside the station. So it can be either way. So if it's internal, meaning it's included in the NIC, or if it's external, meaning there's a special hardware that we put installed on the transmission medium. So internal and external interface are passive devices. Has the reason here we call it as passive interface. So it means that they do not repeat the signal they receive. So in order to avoid the signal reflection, they just pass the signal to the station at the same time to the rest of the bus, and the signal becomes weaker as it goes through the bus. So in a bus topology, the connection is multi-point. So a transmission from one station will be received by all other stations. So each station checks the destination address of the frame to decide if it should keep the frame or discard it. So as I have mentioned earlier on, there are three types of addressing. So let's us look how bus topology allows all three addressing. So it allows unicast, where the address must match the physical address of the station or the packet is discarded. So the multicast, the address must match the group address of the station or the packet is discarded. Or also they allow broadcast, where the station can keep the frame. So basically here the mechanism under unicast operation. So here the mechanism for sending a unicast frame from one station to another. The frame is received by all stations, but it is discarded by all except the unique destination. So what happened here is, if you look here, if station A sends a packet where the sends a frame where destination is C, so it will send the frame to all direction Um, but um, even though station B, which is not the intended sender, receive the frame, so eventually the frame will be discarded. So hence the reason why we allow the unicast addressing in the bus topology. But for the station C, who is the intended destination, so once the data received, they will keep the frame. So that is the situation if we use the um, we pro, we transmit frame or using the unicast addressing. And next, if we are sending it through the baseband, where the transmission is bidirectional, so the bus can transmit frame in both direction. So when a signal sends a frame, the signal is propagated to the ends of the bus. So for the passive interface, which is the transmission medium will not amplify or modify the signal. So here, if we are using the broadband, as we know, broadband is for the uh, analog signal, so the transmission is unidirectional. So in first case, when a station send a frame, the signal is propagated in only one direction. Means it, okay, if we look here, okay, so this is the for broadband case. So transmission need to be unidirectional. So in the first case, when a station send a frame, signal is propagated only in one direction. So like in this case, first the signal will propagated on the left, and the second one, okay, and the second one, it needs either two bus using the same frequency or one bus using two frequencies. So meaning in second case, there must be a converter at the end of the bus to convert from one frequency to another. So if at the first time, the message is propagated on one direction, which is to the left, so frequency converter will reverse the propagation of the receiving frequency, so that now there will be two ways propagation. So let us look at the bus topology for a second. Okay, bus topology using broadband transmission using one frequency but two bus. Okay, this one, two frequencies, one bus, where we use frequency converter to reverse the frequency of the propagated messages. So now for the two buses, broadband transmission using the same one frequency. So in here, if you look, so both systems are example of broadband transmission, but the first uses a frequency division on one bus, while the second uses spatial separation with two bus. So here, two separate bus are used for communication. One-way propagation occurs in each bus. So one bus is dedicated to transmitting data in one direction, while the other bus handle the opposite direction. So here we have the passive head end, which is used for signal distribution. So the system relies on a single frequency, but the dual bus configuration ensure unidirectional communication on each bus, providing clear data flow without interference. So each bus has its own terminators to prevent single reflection. So that's the main difference between the second case and the first case. So in the first case, there are two distinct frequencies are utilized, which is the sending frequencies, which is used for sending data signal, and we also have the receiving frequencies used for receiving data signal, where we have the frequency converter to manage frequency switching between the sending and receiving. Alright, so next, let's look at the bus topology. How can we remove frame from bus? So each medium interface passes the signal to the next interface. So the signal is weakened but never removed. So terminators will perform the removal operation at both ends of the bus. So when the frame reaches one end of the bus, the terminator remove the signal frame from the bus. So usually for the bus topology, we use the coaxial cable. So it is used by 10 by 5 and also 10 by base 2, 10 base 5 and 10 base 2 Ethernet network. So also using token ring bus networks, so the physical topology is a bus while logical topology is a ring. So the characteristic is failure of the medium seriously affect the network because the interface are passive, so their malfunctioning does not seriously affect the performance of the network. And because the interface are passive also, there is a limit of the length of the network unless repeaters are used. So basically, the 10 base 2 and 10 base 5 Ethernet network are now obsolete and is already be replaced by modern Internet standard like 10, 100, 1000 base T, which is used twisted pair of fiber optics, which is this one 10 megabyte, 100 megabyte, and also 1 gig, 1 gig cable. So basically, in the modern networking in recent days, so bus topology is largely obsolete because what has been commonly used before, like 10 base 2 and also 10 base 5 has been obsolete and has been phased out. So modern network have transitioned to star topology and its variants due to the following reason. The first one is a scalability issue, single point of failure, meaning adding for the bus topology, adding device or extending the network in a bus topology is difficult and prone to error. And there is single point of failure where a break in the central cable disrupts the entire network. And also there is a limitation in terms of performance because bus topology does not perform well in large or high traffic network. And in LAN networking, so there is emergence of switching technology where the star topology is widely adopted, and we also combine it with the Ethernet switches, which provides better performance, scalability, and also fault tolerance. So now let us look at the ring topology. So under ring topology, what happened here is all stations are connected through the transmission medium ring through the medium interface. But notice here that the interface is no more a passive interface. So you can see that there's no terminator, and there is a unidirectional transmission. So for the addressing method, so similar to bus topology, ring topology allow unicast, multicast, and also broadcast addressing. So each station checks the destination address on the receive frame, and for the destination unicast addressing, so it must match the physical address of the station. If yes, the packet is copied and regenerated and passed to the next station in the ring. Otherwise, the packet is only regenerated and passed to the next station without being copied. So if you look here, um, unlike the bus topology, so the concept of the ring topology is the packet is passed from one station to another, and if the station is the intended recipient, so the packet will be copied by that particular station. But if the recipient is not the intended recipient, the recipient of the packet is not the intended recipient, so basically the packet will be only regenerated and not being copied by that particular recipient. So for the ring topology, it also can handle multicast and broadcast if the implementation allows the frame to be removed by the source and not by the destination. So let us look at the medium interface. So the interaction between the interface and medium through the medium interface. Again, we have the similar to bus, we have the internal and external interface, but here the interface, rather than working silently like in bus topology, but the interface here is an active interface because they will repeat or regenerate the signal they receive. So that's the reason why it is called active interface. So under ring topology, we can have the point-to-point connection, where connection between two media interface is point-to-point. So the output of an interface is connected to the input of the next interface by a point-to-point link. If we want to look at the transmission, so there are three types, which is unidirectional transmission, uh, baseband, and also oh sorry, we don't have broadband here, so we don't have broadband transmission, so we only have unidirectional transmission and also the baseband transmission. So for the unidirectional transmission, the transmission is unidirectional. Signals are propagated in only one direction from one interface to another, and this implies that each station has a previous station and also next station. So let us look at the interface state. So here, as we know that the interface is, of the ring topology is active, but it can be divided into um, two main status, which is the operational and also bypass. And also under operational, we have the listen mode and also the transmit mode. So what is the difference between operational and bypass mode? So for operational mode, so the station interacts with the ring, while in the bypass mode, the station is skipped to maintain ring functionality, meaning um, the signal or the packet will not be regenerated. Alright. So and then frame processing mode. So listen mode, process on the frame addressed to the station. Forwards are the frames unchanged. And for the transmit mode, the station sends its data onto the ring and inject frame into the rings for communication. So we have two things that we need to understand here. The first one is the operational mode, either this operational or bypass, and also second is the frame processing mode, where the frame is under listen mode or under transmit mode. So in the listen mode, the station either has no frame to send or it is not allowed to send, meaning this station cannot do anything. So a frame received by the interface is regenerated and sent out with a 1-bit delay to differentiate the input and output, and the station receive a copy of the frame. So basically, listen mode is under operational, and it still regenerate, the frame is still regenerated, but the thing is the station are not doing anything. Okay, the station has either has no frame to send or is not allowed to send. So basically here, the processing, regeneration of the frame still happened, okay, but the station is not allowed to do, is considered has no frame to send or not allowed to send anything. So and when they send out the frame, so the received frame, so they send out with a 1-bit delay so that it can differentiate itself, that differentiate the station itself from input and output. So under listen mode first case, okay, let's see here. So the first case, the station connected to the interface is not destination of the circulating frame, and the destination address of the frame does not match the physical address, meaning what are the in which situation the station is under listen mode. So it is when the station connected to the interface is not the destination of circulating frame, and the destination address of the frame does not match the physical address of the station. So what happened here is the station discard the frame, however the interface regenerate the frame and send it into the ring, meaning the station discard the frame for itself, but they still regenerate it for to pass it to the next station. So under listen mode second case, so the station connected to the interface is the destination of the secreting frame. The destination address of the frame matches the physical address of the station, and the interface check to see there is no error in the frame and send the data portion of the frame to the station. At the same time, copy every bit to the output while changing some of the bits to show that it has checked the frame and received a copy of the data. So that is the second case of the listen mode. So for the transmit mode, how it happened, so the station sends its data onto the ring. Okay, the station sends its data onto the ring. So this is the part where the ring is. So the interface received the incoming stream of bits from the previous station, and they will deliver relevant data to the connected station and accept outgoing data from the station to forward to the next station in the ring. So basically, the received frame will be discarded after the frame processing, and the new frame created by the station is put onto the ring for transmission. So the key component here is the delay module. So the delay module in the interface represent the time required to process and forward the frame to the next station. So let us look at the switching between mode, which means switching between the listening mode to transmit mode and the transmit mode back to the listen mode. So if the switching between listen mode to transmit mode happen when the station transitions to transmit mode when it has data to send, and the network protocol such as the token passing mechanism grants it permission to send the data, while the transmit mode and the station will switch from transmit mode to the listen mode if the station switches back to has finished sending all data and its permission to send data has already expired. Next, let us look at the bypass state. So basically, when a station is under bypass state, it means that the station is not part of the ring and can be used to remove as an idle station from the station of the ring if the station is off or not functioning properly. So for the station that is not working, working properly, so basically we can put it as bypass status. So we have to understand that to remove frame from ring, because ring does not have terminators, unlike a bus topology, where in the bus topology the removal of the frame is done by the terminators. So one station must be responsible for removing the frame from the ring, otherwise the frame will circulate forever in the ring cable. So ring's transmission medium. So because it is an active because ring topology use the active interface, so the signal will never die. Okay, because each interface will repeat the signal, unlike the bus topology that use passive interface. So basically, frame removal can be done by the destination interface or by the source interface. So there are few ways of removing frame from ring. First, removal by the destination. So let the interface connected to the destination station remove the frame from the ring, but it has some drawback. First, the destination station must send another frame to the sender if acknowledgement is needed, because say for example we are there are many protocol that requires acknowledgement. So basically, if we are using the removing from frame method, so it is the destination station which discard the frame need to send another frame to the sender for the acknowledgement. Second, it won't allow multicasting and broadcasting because the first destination remove the frame from the ring. This is removal by destination example. Say for example, a frame is sent from A, and the destination is here, assuming that is C. So here on B, when the frame pass through B, so the frame will be regenerated. The signal will be regenerated and will go to C, and then when the C has already copied the data portion of the frame, the frame will be removed by C. That's how the removal by destination happened. So now we have another method to remove frame from ring, which is removal by the source. So let the frame circulate from the source to the destination station back to be source. So the source can be then removed from the ring. The returning frame can serve as an acknowledgement or negative acknowledgement. So meaning, even though the packet or the frame has arrived at the destination, so the frame need to be circulate back to the source. So the one who can uh, remove the frame is the source. Okay, so by right, when the source receive the frame, so the returning frame can also act as the acknowledgement. Okay, so the destination station can change some bits in the frame to positive or negative acknowledge the receipt of the frame. So basically, this will simplify the broadcasting method because several stations can receive the frame and copy without removing the frame from the ring. Because if we are using the removal by destination, because multicasting, we need to send a frame to many. So if if the frame is has reached one destination, and the destination has will remove the frame, so basically we don't have another frame or another packet for the next destination. So basically, long time ago, I mean, I mean, uh, 20, 20 years ago, the ring topology is used in high-speed network, and in the network backbone, like in FDDI, in SONET, in token ring. So basically, this topology is commonly used long time ago for high speed network and also backbone, internet backbone. So um, there are but now we don't really use it anymore, because this kind of topology has become obsolete. So there are a few reasons, because the failure of the medium seriously affects the network, because the interface are active device, so and always active, so there is a limit on the length of the network, and because each interface will create delay to differentiate the input and output, so the total propagation delay is dependent on the number of stations on the network. So we can see that the network topology has been phased out. So now we look into the one that is commonly used now, which is the star topology. So the star topology, a station is connected to a central node or hub. So basically here, again, what are the role of the interface? So we need a medium interface to connect the station and to medium. So the medium interface include in the NIC can be part of the station itself. So basically, unlike ring and also the bus topology, we use internal interface for star topology. So basically, most of the connection are point to point, in which the connection between any station is mediated using the hub or switch. And to make the operation fully duplex, so two links are normally provided between the hub and each station, one of each direction. So in the star topology, we have unidirectional propagation. So the transmission can be either baseband or broadband. So baseband transmission used with the guided media, and the broadband transmission used with the unguided media. And if we would like to talk about the hub, but the thing is, because we don't really use hub anymore, just FYI, we have two type of hub, which is the passive and also active hub. For passive hub, it receive frame from incoming link and propagate it to all outgoing link without modification or amplification, while the active hub receive the frame from an incoming link, generates it and sends it to all outgoing link. So if we have here switch or hub, so switch is if if we have here switch instead of hub, so switch is a device that can recognize the destination address. Switch receive a frame from an incoming link, finds the destination address and route the frame to the appropriate outgoing link, and only destination station receive the frame. So for a hub, if we are using the hub, the topology is physically a star, but logically it is a bus. So a frame sent by a station is received by all station. So here, when we talk about the bus, so we send the signals or the frame to one direction, and if the frame is not intended to the recipient, so the recipient will discard it. So to remove frame from network, from when a frame received by station, it is automatically removed from the system. So the station will trace the frame. So in terms of addressing style topology, if you are using hub, it's exactly like bus topology operation. But again, in the recent years, we no longer use hub, so the star topology will use switch, and the switch will make the decision. And if the address is unicast, the switch send the frame to only the intended recipient. And if the address is multi-cast address, the frame is sent out to several output links. While if the address is broadcast, this frame is sent out to all output links. So as we have mentioned earlier on, internet implementation, we use 10 base TIFF, 10 megabit per second, fast Ethernet, gigabit Ethernet, ATM, and also WLAN. So the characteristic is failure of medium does not seriously affect the network, because we have one point-to-point connection. So it only will affect that particular connection only, and the malfunctioning of station does not seriously affect the performance of the network. But the major difference here, the failure of the hub seriously will affect the network, meaning the failure of the centralized switch or centralized hub will affect the whole network operation. And then we have the mesh topology. So mesh topology is usually used in data center. So dedicated point link to every other nodes. So basically the advantages is to provide redundancy, to provide backup, and to provide a more robust and secure network performance. However, the disadvantage is difficult installation, and also we have a problem with space and also cost. So we have hybrid topology, where the main star topology with each branch connecting several stations in a bus topology. This is to share the advantages from various topology. So I think that's it. So let me go to here. Okay. Okay, so I think that's all for today. So thank you for listening. Assalamualaikum, and selamat sejahtera.